Okay, some of you have been asking for some help with some web work. And this is for Module 8, Math 65, and I'm your instructor, Mickey Josie. I'm just going to go through a few of the problems that got sent to me. So the first was on unit conversions, and the tricky thing is I actually did take this right here, this screenshot I took from our conversion chart that's in your, it should be in your desire to learn. So I just took a screenshot of this because I never memorized this, but it's saying here that 1 byte is equal to 8 bits, and then all the way down the line, terabytes, did I say that? And gigabytes, okay? So this question right here is asking, it wants you to convert 72 TBs, which is terabytes, to gigabytes. And so we're going to use that conversion factor right there. 1 terabyte is equal to 1024 gigabytes. And part of the reason why we're using that number, that's actually a base 2 number. So that comes from binary, but you're going to notice that these are the conversion factors right here. So when we say conversion factor, we're using this idea that 1 TB is the same thing as 1024 GB, gigabytes. And so when we set this up, we can say 72 TB over 1 to make that into a fraction because it's not a rate. And then we want to multiply by the conversion factor. We want to set it up so that just like fractions, it will cross cancel. So the idea of fractions is the reason why this is like fractions is because let's say you're going to multiply 1/4 times 4/5. Okay, you can multiply straight across with fractions. You can go 4 times 1 is 4 and 4 times 5 is 20, but you will end up needing to reduce this fraction. So the idea here is if you cross cancel the 4's, then that is the same thing as 4 over 4 is 1. And so you're going to get 1/5, which is an equivalent fraction. So for this one here, I want to be able to get rid of the terabytes. So I'm going to put that on the bottom. 1 terabyte is still equivalent to 1024 gigabytes. And so this is the same thing as 1. Since these are equivalent, these units are equivalent, we're setting up this conversion factor to multiply by 1 in order to not change the value. So then that allows us to cancel out the terabytes and we'll be left with the unit gigabytes. And so if we multiply that out, you'll see here's the answer is 72,728 gigabytes is equivalent to 72 terabytes. And so that's what we would do is multiply those things together, and that's the answer we would get there. And I like how here the formatting is showing you, showing all of the work going vertically and with the equal signs lined up. Okay, so for the next one here, it wants us to convert between KB to bits. So KB, in this case, if I look up KB, oh, here it is. And this one is the one we want because we want bits as opposed to bytes. Is that right? No, K little b. Oh, this is K big B. So this is kilobytes as opposed to kilobits. Okay, so we want kilobytes and we're changing that to bits. So we're gonna actually have to do 2 conversions here. We're gonna need both of these. So 1 kilobyte is equal to 1024 bytes. And then we have to change 1 byte to 8 is equal to 8 bits. So that's why you see these twice. So we're going to start out with 4.45 kilobytes. And then since we want to get rid of kilobytes, we put kilobytes on the bottom. And what's the abbreviation for bytes? Is a big B. And if we go back to that conversion, we have 1 kilobyte is equal to 1024 bytes. And then we want to change that to from bytes to bits. So I'm going to put the bytes on the bottom, the bits on the top, and it's saying that 1 byte is equal to 8 bits. So 1 byte equals 8 bits. And then you can see that all of these will cancel. This unit cancels here, this unit cancels here, and what we're left with is the bytes, no, the bits. And so we're just multiplying that out. So there's where you see this 4.45. I didn't mean to turn that into an arrow. Times the 1024 times 8, and that is what we get there with the decimal point. So once you use your calculator to multiply that out, and that's literally the same thing. I just wanted to show you how I would write it out, and then go ahead and multiply the numerators and the denominators. In the denominator, you still have 1 times 1. You know, they put this over 1 as well, because any whole number can be made into a fraction by putting 1 underneath. Okay, now let's come down to this unit conversion. So anytime you have area or volume, you're going to have to square or cube the units. And that's something that's really tricky for people. So if we think about for a minute, if I have a square, and that's where we might have area. So area is equal to length times width. And in this case, it's perfect. It's a perfect square. So it's just going to be the same thing as area equals the side squared, side times side. So let's say that one side is equal to, well, here we're talking about meters to millimeters. So if we had 1 meter in length, that's equal to 1,000 millimeters. And that's also on your conversion chart. But if I have this length, that's the length. Let's say that we have the width is also 1 meter, or the other side is 1,000 millimeters. Now the area would be 1 times 1 would be 1 meter squared. And then if you were to find the area in millimeters, it'd be 1,000 times 1,000. So 1 meter squared is equal to 1,000 squared. 1,000 millimeters squared. And when you square that, you're basically going to get 1,000,000. I have 3 zeros and then another 3 zeros, right? 1,000,000 millimeters squared is how that works. Okay, so if I want to take my tiny little area, which is 2.2 millimeters squared. Imagine, you know, a millimeter is really tiny. So this area is equal to 2.1 millimeters squared. We're going to set that up 2.1 millimeters squared times, now I want to get rid of millimeters. So I have 1,000,000 millimeters squared is the same thing as 1 meter squared. And that's why, and I put this over 1 as well. And that's why these units are going to then cancel. And essentially what we have is 2.1 meters squared. Oops, I didn't multiply. And you could say this is the same thing as 10 to the 6th. So if we move that up, it would be times 10 to the negative 6, because that's the same thing as 2.1 divided by 1,000,000. If you divide something by 1,000,000, meters squared, okay, if you divide by 1,000,000, you're taking your number and you're moving the decimal over 6 places. So I would insert 1, 2, 3, 4, 5, 6 zeros, put my decimal there, 221 millimeters squared. They have it, the answer here in scientific notation. I'm not sure exactly if it would accept it either way, but that 10 to the negative 6 is the same thing as dividing by 1,000,000, because when we have 1 over 1,000,000, that's the same thing as 1 over 10 to the 6, which is 1,000,000. And then that's the same thing as 10 to the negative 6. So these are all equivalent here. And this comes back to our discussion on laws of exponents. Okay, so if you were converting volume, I don't have a volume problem that got sent to me, but let's think about volume for a minute, because that's something that people often struggle with, is this idea of why do we have to cube the units for volume? But let's say I had, and this is like a common situation when you're like ordering materials for, let's say, a garden. So if you had something that's a cubic shape that's three-dimensional, that was 1 yard by 1 yard by 1 yard, so the volume there would be 1 times 1 times 1, or 1 yard cubed. You'd be multiplying it by itself. Well, 1 cubed is 1. 1 times 1 times 1 is 1. So 1 cubic yard is that volume. Now, if you wanted to convert that to feet, each yard counts for 3 feet, right? In a linear distance, meaning like a straight line. But if I wanted to find the volume of that, I would have 3 times 3 times 3, or 3 feet cubed multiplied by itself 3 times. And 3 cubed is, anyone know? It'd be 3 times 3 is 9. 9 times 3 is 27 cubic feet. So this would be, anytime, you know, if you were going to change from cubic feet to cubic yards, you have to take those or anytime you're going to change any kind of volume measurement, you're going to have to cube that unit conversion. Okay, same thing if I said, oh, well, if I had 1 foot, this one is going to be really a lot more challenging, but if I had 1 foot cubed, 1 foot, oops, 1 foot, let's say I was going to change that to inches. This is going to be a lot more dramatic. Well, you know that 1 foot is 12 inches. So if I take the 1 foot and 12 inches are equivalent, if I wanted to find the volume of that, or that, you know, if I was going to convert volume, then I would have to cube that. So 1 foot cubed, just because I ran out of space, otherwise I'd go vertically, is equal to 12 times 12 is 144, and then 144 times 12, 144 times 12 is 1,728 inches cubed. So if I was going to cube, you know, change something from cubic inches to cubic feet, or then again even to cubic yards, I would be having to use these cubed measurements. Just like if I'm considering something about area, I have to square the conversion. Okay, and then there was this problem on geometry formulas. So for the formulas, these come from that same, I think you have a geometry formula sheet. But for the most part, you know, these make a lot of sense. You're going to use perimeter. This one was perimeter of a rectangle. So you have 2 lengths and 2 widths. And for perimeter, you're adding that all up. So you could either write it like this, or perimeter, you could write perimeter is 2L plus 2W. This is the same thing. You use the distributive property, so that's perimeter. And then area, here we have length times width, and that's going to give you the area of the inside. Perimeter goes around the outside. This one is the area of a triangle. So if we have a square or a rectangle and we cut it in half along the diagonal, what we find is that we have the length and the width, which those are interchangeable with base and height. Well, we use height because we're finding that at a 90-degree angle. But you can see that I'm taking half of the area. So the area of a triangle is either 1/2 base times height, or you can say it's the base times the height divided by 2. That's the same thing. So right there, that's the area of a triangle. This was the area of a square, perimeter, or rectangle. And then for circumference and area of a circle. So when you have a circle, the area, or sorry, the circumference of the circle, we'll do that one first, is the distance around the outside of the circle. That's the circumference. The circumference, it happens to be, circumference is pi times the diameter. And the diameter goes all the way across, whereas the radius is half of that. So we could say that's 2 radius times pi. And pi, since pi is approximately 3.14, and it goes on for infinity, that means that this diameter here fits around the outside of the circle a little more than 3 times. There's 1, 2, 3 diameters, and then so 1 diameter, 1 diameter, 1 diameter, and then here would be 0.14 diameter, approximately. Okay, and so then for the area of a circle, what we do for the area of a circle, we have, here's our circle, we take the radius. So there's the diameter, goes all the way across. The radius is half of that. And we're going to take pi, which remember is approximately 3.14. And what's interesting to notice is if I took, actually I don't really like that yellow on there, can't see it very well, but if I were to take the radius squared, right here is a radius squared. And if I had 4 of them, that would be too much. That's a radius squared. This is a radius squared. And here's a radius squared. And see, if you had 4 radius squareds, oops, not pi, 4 radius squareds, it would be too much. So instead we have pi number of radius squareds, which actually is about 3.14. And if you were to take off these outside edges, that might be what's left, you know. So the area is, and you're using, on WebWork, you're using pi as pi radius squareds. So that right there is the area of a circle versus here is the circumference, is like perimeter, but of a circle. Now we talked about the volume of a rectangular prism, and volume is how much would fit inside. So that's going to be 3-dimensional, and this is cubic. These units are cubic. These units are square for area. Area is also always a square unit. And circumference and perimeter are going to be linear. So that would be something like feet. Yeah. This last one here is the volume of a cylinder. So the volume of a cylinder is, we take the area, pi r squared, the area of the circle, pi r squared, and we're going to multiply that by the height. And that's how we find the volume of a cylinder. And then the last one asks for, I know I forgot to put the instructions on here, asks for the area, no, it doesn't ask for area, sorry, it asks for volume of a cylinder, oops. Volume of a cylinder or a rectangular prism. Volume of cylinder or rectangular prism. Maybe, which is basically that, you know, rectangular shape. It's 3-dimensional. So what we have here for this one, this is going to be volume equals base times height. Now we're using the big B to represent the area of the base, because you notice that when I find the area of a cylinder, I'm finding the area of the base and multiplying it by the height. When I'm finding the volume, did I say volume of cylinder? That's what I meant to say. When I'm finding the volume of a rectangular prism, I'm multiplying the length times the width and the height. So I'm finding the area of the base and then I'm multiplying it by the height. So that's why we use a big B here to represent the area of the base. Okay, just a few more. So here is a geometry application. So once we have that formula for the area of a circle and the circumference, we can kind of work backwards. So if we have a circle and we know that the circumference is equal to 43 centimeters, how can we find the diameter? And then how do we find the radius from there? So since we know the circumference is equal to pi times the diameter, if I say that pi times the diameter is equal to 43, then all I have to do to get diameter by itself is divide both sides by pi. So I take the diameter is going to be 43 divided by pi, and on your calculator, I would use the pi button. So that's the worked out instruction there. But on my calculator, I have a pi button. So I go 43 divided by pi. And I'm going to get this answer here, about 13.687. Now you will eventually have to round. So probably you'll want to round to two decimals at least. Although it looks like they kept four decimals here. So the diameter is, and we say approximately using the wavy equal sign, 13.6873, and that decimal will keep going, and the units are centimeters. And then if we want to know the radius, well, the radius is half of that. So the diameter is equal to the radius times 2. So if I have the radius times 2, and actually I don't really like how I wrote that. It just looks like too much like an exponent. So we know that the diameter is 2 radius. So if this is the diameter, I have 2r equals 13.6873. To find the radius, I'm going to divide that by 2. So that's going to be approximately, if I say 13.6873 divided by 2. Oops. 13.6873 divided by 2. I get 6.84365 centimeters. Okay, so that's going to be that answer. So those were both incorrect. So your first answer is here, and the second one would be like this. All right, and I think this is the last one I got sent, was a geometry problem. So this is an application, and here we're using similar triangles. So for similar triangles, there's going to be a number of ways that we can set this up. But what you're going to notice is that what's happened with similar triangles is that they are proportional, meaning that you either multiplied or divided each side by the same amount. And so then we can use a proportion. This side corresponds to this side 15 feet. And then we can either use the other length here would be the same as this one because they're forming a 90-degree angle, or you can use this hypotenuse because this looks like a right triangle. So I will use whichever one comes to mind for myself, as opposed to maybe it might be slightly different than this proportion. So why don't I go ahead and use the corresponding sides. I'm going to use the yellow sides. No, that's actually what they used. Well, it's fine. So if I say x over 15, that means this is my missing side, my short side, over the other short side. So they did short side over short side of triangle, our missing triangle, triangle A, let's say, over triangle B. And then we want to do the corresponding sides. So if we have 64.8 is on our triangle A, over 36, which is the corresponding yellow length on triangle B. And then, so that's our proportion, how it's set up. Once we have a proportion, all proportion is just a set of equivalent fractions. So 1/2 is equal to 4/8. These would be considered a proportion, just any two fractions that are equivalent. Well, it turns out with equivalent fractions, the cross products are equal. So 1 times 8 is equal to 4 times 2. And that's true because 8 equals 8. So if we have triangles that are proportional, we can set up a proportion. If they're similar, then we know that they're proportional. And so we can cross multiply. We have 36 times x is going to equal 15 times 64.8. And then how do I get x by itself? Well, I'll divide both sides by 36. And so x is equal to 15 times 64.8, which they have here as 972. And then 972 divided by 36 gives us 27. So I hope that was helpful. Feel free to send me any other questions that you'd like to go over.